My name's Rob, I work for OpenTable, so shout if you need anything. I give this guy a quick intro, so maybe you guys probably heard it before. So OpenTable, we do restaurants and reservations. So we're in the business of trying to match diners with restaurants. We put software and hardware into restaurants for them to manage their business. And we provide websites and mobile apps for diners to find restaurants. So we have like this kind of both sides of the network. We have a fairly diverse technology base, kind of a lot of JVM, sort of legacy C#, no F#, unfortunately. Node is a front end sort of page generation service language. SQL Server, Postgres, Mongo, and Springall's other stuff in there too, and yeah, it keeps us going. So it's enough from me. I'll let these guys take it away.
So yeah, in case this was not clear, you're in the wrong room. Like this is the F# user group. It's a group. Have you been to the group before?
I've been once this year.
So is there anybody there for the first time? Because I think otherwise I recognize pretty much everyone. So I think probably not. So I can keep it short. So yeah, we're there because we care about F#, and the goal is to find a place where we can just learn together in a friendly environment from each other and all of that. And also one point which Will made at some point was if you don't know what functional programming is, if you're a beginner, you're actually very welcome, and we want to help people step up the game or get why it's awesome. So if you have if you know beginners who are great and don't know really functional programming, please bring them in. Plan tonight, I'm going to make a couple of announcements. Then Ryan will be speaking, and at 8:30-ish, we're probably going to vacate the premises. And if people want to chat some more, we're going to go to Murphy's, I believe, like the most generic Irish bar name possible, and have a Guinness or something like that and talk more. So if you're new to F#, so I guess that's not the case. So you probably all know what F# is, functional first, cross-platform, runs on everything, open source. The two things you probably want to know, one of them is about fsharp.org, so that's the site for the F# Foundation. Is anybody in the room not a member of the F# Foundation? Just curious. Okay, you should be, for multiple reasons. See, get out of here. So the fsharp.org is the place where you would so it's a non-profit. It exists outside of Microsoft, and the idea is a home for information around F#. So it covers things like how do you set up F# on the Linux box, how do you set up on a Mac, how do you do machine learning with it, how do you do the web with it, all these type of things. And the other side, also testimonials, if you want to convince your boss that F# is awesome, you have a full page of companies using it and why they use it and why it's awesome. And also, there's also membership, which is free. At least everybody can be a member. Then if you want to support with financial support, you can of course do that. And we are starting to do interesting. So I'm a member of fsharp.org. That's also why I'm pushing it maybe so hard. But we're trying to do. We spent lots of time recently working on paperwork and uninteresting things, like getting it as a proper 503c. That's done, and now we're working on more serious programs. So people are working on setting up mentorship. If that's a topic you're interested in, go check it out. Also, one thing we have been discussing with some people in the Slack channel was, can we have a program where we can help user groups, pay travel for speakers to go to user groups and help user groups find speakers, so that type of thing. So things are happening, and so check out what's going on there. The other place you probably want to go if you want to meet the community is the two places. One of them would be Twitter. It's probably the one reason I'm on Twitter. So if you use the hashtag F#, the legend goes, if you use that hashtag, you're pretty much guaranteed to get a like or a retweet. There's also a non-negligible chance that Don Simon will actually like or retweet. And otherwise, there is a very good Slack channel too, functional programming, slack.com, which is cross-functional, and there is a big group of people who are chatting over there, so it's also a good place to go. Upcoming events. So next month, still OpenTable, March 16, we're going to have Mike Payne speak. So I think he's going to come a bit later tonight. He's been building an intranet solution using F# through and through. And so he's going to talk us through what he did, what worked and all that type of stuff. So I think that should be a fun one. On April, like it's still it's still not sure. I consider speaking, but if anybody else wants to speak, I will take that as well. And on May 17, Darren Platt will be speaking. So actually, I will ask people what do they prefer, because Darren Platt is this guy who's working for a company called Amaris. What they do is they do bioinformatics and manipulation of DNA essentially, and he's using F# a lot for that. He built essentially a DSL so that geneticists could say this is how I want to change the genes, and then it actually creates new genes with new yeast and stuff like that. So, and that guy is a beast. So, and he's got 2 topics which he can talk about and propose, and one of them is essentially bioinformatics with F#, what he's doing. And the other one is F# for Python developers, which, no, F# for Python developers, probably. That's probably the more this direction. And so I'm curious, who would be interested in the first one, which would be more bioinformatics? And who would be interested in F# for Python developers? So now the question is that it's probably not the right room, though, because if I do this for Python developers, we might get new people.
But if it is numerical analysis, then okay.
Yeah, but I mean, it's if so, it looks on one hand is people seem to be more interested in bioinformatics. On the other hand, is I think the Python talk would be interesting in that we could get actually people from Python, which are not the people who are currently in the room. So it's probably not the right audience to ask that question. So we'll ignore the input.
Sorry. Sometimes I'm pushed into using Python just because of the numerics. In conditioning matrices and decomposition, that kind of work. And I try to say, can you use F# in there? And people are very sensitive.
Yeah, I could do a talk also on numeric analysis with F# in general. But I think the particular experience with Darren is interesting because in bioinformatics, people used to use Perl a lot 20 years ago, and he was pushing very early on for Python. And now everybody's using Python. He's been pushing very hard for F# because he thinks it's better than Python. So I think he's the right guy because he's been using both very heavily. So that could be interesting. So I think about that. We'll just toss a coin and see what happens. So need your help, usual ones is if people want to help organizing events, I like organizing, but it's more fun as a team. So if you have any interest from doing things I don't know, greeting people, taking pictures, emceeing in the beginning, all these things, that would be awesome. The biggest help is the one which is highlighted, I think it's yellow, so I'm colorblind, so I'm not sure, but spreading the word, the biggest thing you can do for the user group is if you find it's interesting, people who are smart, just bring them over. And actually, I'm going to put an incentive is starting next month. Is anytime somebody brings a new person to the group, is I have Pluralsight 1 month video. So it's bring a new person in, and you will get 1 month free subscription to Pluralsight. If you have sponsorships, money, stuff like that, that's awesome. Thanks to OpenTable for having us, specifically thanks to Rob and also to Jason. Jason is the person you might not have, actually who probably greeted you downstairs and who's responsible for the food, the drinks, and the organization. So a word of thank you to Jason when you leave would go a long way. He's awesome. So let him know that he's awesome. Yeah. F# news. So I had one thing I wanted to announce specifically is on March 4, there will be an event called F#Conf. So if you look at it, either under that name on the web or on Twitter, you're going to find it. So I'll let you guess what it is. It's an F# conference. So it will be full day, free, streamed with Channel 9 in cooperation with the foundation. And it will be 1 day of talks with top-notch speakers covering lots of topics. So if you are either curious or if you know people who are curious and don't know about F#, that would be a great time to check it out, and please spread the word about this. The bigger it is, sometimes people say, hey, F# is a small thing, so the more people show up, the better everyone will be.
It's going to be live or recorded?
Live. So I have another announcement. Is there is a conference in Boulder, Colorado. I think it's in May, called LambdaConf. So they pinged us. It's a good functional programming conference. I think it's 2 days or 3 days, and they have also workshops covering lots of things, some F#, some Haskell, some Clojure, all these things. And they pinged us. And if you're interested in a discount code, I can get you a discount code to the group or something like that. So that's what I had on announcements. Does anybody have announcements, maybe job openings, maybe things which people should know about hiring? Good. So
yeah, if you're interested, let us know. But yeah, we're always hiring. Can't get enough right now.
Enough sharp.
Not enough shot now.
Other announcements?
Yeah, that functional languages. You do actually Scala and JVM?
Yeah, we do Scala. And there's an office, a company required in Chattanooga, and they do Clojure. And then we have JavaScript, which is delayed.
Let's not go there. Ward, welcome.
I'm obviously too early. I came for the beer and
And we're starting the main event like in a couple of minutes. So you're perfectly on time. So you said like you were.
If people are using Xamarin with F#, then I would encourage you to give the preview of our Xamarin CS6 a try, which I think you can get from xamarin.com/releases/current. There's a spot there that our previews and alphas are linked from, and there's a ton of F# fixes and new features, shared project support, PCL support, syntax highlighting, improvements, just general stability improvements. So it makes F# a lot easier to use on the Mac. And if you find any problems with it, give us a shout because it's.
How should people give you a shout if they find something?
So actually on that page, I think there's a link to our Bugzilla, but it's bugzilla.xamarin.com.
Cool.
I think most people have seen Bugzilla at some point in their life, so it's shit. Lots of bugs, and they will eventually find their way.
Yeah, so lots of love and for F# in the latest versions, things coming from Xamarin. So take a look. Other announcements or things people should know about?
I have a little $100,000 a while. If anybody can shorten my one page of F# code. I took Thomas Berdichek's example 3D web, and that was about 40 lines. I shortened it down to like 30 lines. If anybody can make it simpler.
Shorter or simpler?
Simpler is harder. So if you could do it, it's a nice exercise to try. It's a machine learning example.
You should do that as a lightning talk.
Yeah, you asked me, but I cannot shorten it to 5 minutes. So if anybody else can do it to 5 minutes, they get the one.
Okay. Do you have a link to a repository or something?
Yeah, I'll give it to you.
Put that on the comments, so that people can take a look.
There was another one like that. There were like about 40 lines. Somebody had asked a question, and I gave it back, and it was about 9 lines. And 9 lines were much easier and simpler to see than the teacher's 40 lines.
Mm-hmm.
So I
Cool.
FSNIP and SSS.
Oh, you have it on FSNIP? Yeah, then put the
that's
link.
another one.
Awesome.
So coming from physics background, reductionist, really looking for what is the core problem to solve. So I'm not an expert in F#, so I'm struggling, and maybe you want the perspective of a struggling guy, so you can see. Thanks.
More announcements? Oh.
Yeah, we're hiring a
That's what I thought, but I wasn't sure.
hiring a senior gameplay engineer in F#.
Cool. What do you guys do?
we make games.
We're process of making an MMORTS using Xamarin, and we're also using Erlang for the back end as well as F#.
So if you want to do gaming, F# and Erlang is like talk to these guys. Cool. So lightning talk. So I announced it. It's like I did one last time, and it's like people say that the end of last year we would love to have lightning talks. I did one. Is like what I would love is like I don't want to be the only one doing lightning talks. So it's like they will happen if you step up. So Rob stepped up like next month. You will be doing a lightning talk. So awesome. And if other people want to do that, like any topic goes. Like preferably there should be a connection with F#, but that can be fairly loose. And can be anything as long as it's under 10 minutes, like, it works. And so tonight, so this was what I had to say. So tonight, our speaker is Ryan Riley. So the topic will be domain modeling with types. So Ryan, I have known for a while. He's a Texan, but he's a good person. I know him for like when I started on F Sharp. He's like there was one place which is awesome where I found like tons of information, and that's C for F Sharp, community for F Sharp. So Ryan has been the guy doing this tirelessly for years. Check c4fsharp.net. Like actually tonight the talk will be streamed on C4F Sharp. So you have I was going to say a shit ton, so I'm going to say a shit ton of good material over there. Like I counted over 100 recorded videos, like from going back 6 or 7 years. There are dojos, there is material there, so it's a great resource to check. And he's all around a super nice guy. He's handled the panes of glass. So without further ado, like give maybe Ryan a big hand and let's kick it off.
Matthias has also been helping out with community for F Sharp. The dojos are mostly his thing, and they have been very, very helpful for I think a number of user groups, including this one. If I know correctly. I think most of them have actually been guinea pig here.
That's right.
Thanks for
So,
Thank you.
all right. So this is domain modeling with types. When I first created this, I was going to do it just for F Sharp, and then because I was trying to get it into more .NET community stuff, I actually added some C# examples too, to do a little bit of comparison, just kind of talk about the general approach of using types to help drive like modeling your domain and trying to better understand good design and good practices and things like that in terms of understanding what are you actually trying to solve, how are you actually modeling things, and how that actually makes a difference in what you write. So there will be a little bit of C# in here as well as F#. The example in this is pretty simple, and if you have any questions, please ask them throughout. So without further ado, I'll kind of go through this intro stuff real fast. So I work for Tachius. We are a oil and gas startup doing oil field production optimization. And we've been around for a couple of years now and doing really, really well for our clients. So it's been a really exciting thing to do. We do a lot of F#. We have a little bit of Python for some data science and data physics applications, but most of our data transformation from the ETL layer and also our web application is all written in F#. We have a TypeScript front end and things like that, but it's been quite a lot of fun. We actually have an open source project that we created called Gluon, which does like bindings from an F# web server side and generates the TypeScript client for it. So it actually has like type safe connectivity on both ends for web applications. And that's, you can find that on GitHub under the Tachius organization. It's called Gluon, if you're interested in that. As Matthias mentioned, at Panes of Glass is where you can find me pretty much everywhere, GitHub and whatnot. I help lead the open web interface for .NET stuff. It's basically kind of like a rack or WSGI sort of specification for building web applications. I also run Community for F#.
Is the video of you singing about Owen still up somewhere?
It is on YouTube, yes, from Code Mesh last year. So sometimes I don't get a lot of time to talk, so I make up songs instead of giving a real talk. I'm not doing that tonight, so don't worry. All right, so the objective for the talk tonight is to visualize the distance between two cities by their geographic coordinates. And this sounds like a really trivial example, and it will actually fill the time rather well, which is kind of interesting, because it seems like it should take like 5 minutes to do this exercise, right? But we'll be talking about like just the ways of thinking about types and how to apply this. This is actually lifted out of our application. I mean, it's a really very like fine-grained piece of our application, but it is actually taken from some things we did. So it's sort of a practical example here. Okay, so the process, as Matthias mentioned, I'm from Houston, Texas. Our office is in San Mateo, California, so that's why those two city names are on here. The basic thing here is we're going to pick two cities. We're going to pass those in, look up their geographic coordinates, try to find the distance between them. I'll explain why try is an important aspect here. And then convert from meters to feet. And you may wonder why we were measuring the distance between two cities in feet. And it's because that's the measurement we're using in our application. We're not doing this in our application, but we're using feet. So if we have time at the end, we can go through the process of converting feet to miles or meters directly to miles or something. But just bear with me. It is kind of fun actually to look at the fact that it's like 8 million feet between these two cities. Not useful, but fun. All right, so goal number one. How would you define a city? Again, this is our inputs. We have two strings. I've got like a type constructor in F# here called city. It's taking those strings. So that might kind of give away sort of what I'm doing with the city, but like if you were starting off trying to define a city type, then you know it needs to have like a name that's a string, how would you define something like that?
XY part.
Well, that's going a little bit beyond that. The city in this case is just the name of the city.
How about using a plain string?
Okay, a plain string.
Too obvious.
And how might, well, you know, it is actually,
How about that? Ding.
Yes,
You get to
we
the
have a
point, give 'em
winner.
t-shirt.
all right. So one nice way to kind of document your use of using a plain string is to use a type alias. And in C# you can do that with a using declaration at the top of your file or inside the namespace or whatnot. And this will basically alias string as city. Do the same thing in F# where you just have a type declaration, city equals string. But then there's this question, does this really actually help anything? If you alias a type, what does that really give you?
The least complicated solution.
What's that? The least complicated, okay. There's no performance overhead, no allocations or anything. Is there anything?
I mean, you're basically just saying city is a string.
Yeah.
Literally.
So if I pass it a plain string or if I alias it as dog food and pass it in for city, that would still work.
Yeah.
So it doesn't really protect me. At most, it gives me like a documentation in my code that I'm going to be accepting a city here. I just have to know that that is a string when I'm passing it around. So that doesn't really help a whole lot. Can we do better? I'm going to skip the C# piece. We could do more, and we'll actually show like an example of using C# later on again. But in F# there's a thing called single case union types. So in this example here, we've got a type city, and we have a single union case here called city, which I've found giving this talk in the past that is confusing. So I'm going to come back to this slide, and I'm first going to drop down to this more long form. So now it's a little more obvious what's going on. So there's a type city. I've renamed the case city name so it's different than the type name. And then I've explicitly labeled the different uses here. So this is a type city. You could think of this as kind of like a subclass city name, but it's actually just a case of city. And the city name takes a string. Now this thing is actually a type constructor. I can write a function to get the city out, or the city name out of here. But first I need to get a city. So I'm going to create a city instance. It's of type city, but I use the city name constructor passing in the string to get that city instance out. Does that make sense? What's going on here? If you've done F# for a while, you probably know what this is. And
why wouldn't it call just name? Why call it like constructors?
Or why not even just call it just city and just give it for that specific field where it says string, you can say name, colon,
Yep.
string.
You can do that too. But that name is really just like, again, kind of like documentation help. It doesn't actually,
Well, you can
It's not
add-
an- it's
you can
not something
add
you have to
a
have.
bunch of stuff.
true.
And you can make this like require qualified access. Right?
Do what?
Require qualified access, so it will be CC.name. So it's-
Oh, I see what you're saying. Yeah. Make this just name, not city name. Okay, yeah. That also would work too. Yeah. Yeah, there's a lot of different ways to do this. That's true.
Do you want me to remind you to repeat questions for people online?
Oh, yes, that's a good thing. So there were some recommendations of how to name this better. The case could actually just be name of string. You could also add a parameter name before the string, like city name of name colon string, or city of name colon string, to give it a little bit more information about what the name is supposed to be or what that type is supposed to represent. All right, so I didn't do that.
No, actually, one thing I like in Python, so it's like so-called Zen of Pythons, and one of the Zens says like, be aware of concept of namespaces.
Yep.
And concepts. So here, from the context, it's clear that name is like name of city, right?
That's right.
So you don't need to repeat it.
So you don't need to repeat it. Yeah, that's right. So you don't need to repeat the city name. And Dimitri also pointed out that you could put a required qualified access attribute on top of this type, which would then make you always type city first and then dot the case name. So that would make it very obvious.
Now, what if city
fuck.
Muted. I am so sorry. Wow, I was muted. Sorry, everyone who's been listening.
Or not.
Yeah. I think oh, that's so sad because I was trying to get everything else you were doing earlier. Okay. Sorry, everyone. All right. Should be working now.
You see, people are still connected.
Yeah, that's true. People are still on there.
You're doing a great job.
The slides are interesting on their own.
Now they will drop off when they hear the
Yeah. All right. So we haven't dealt with mixing up latitude and longitude, and sadly we'll have to leave C# behind for this one because we're going to go look at units of measure. So F# has this thing called units of measure. Matthias mentioned this earlier of like ways of like denoting whether something was one type of thing or not. You mentioned degrees being the unit of measure for latitude and longitude, which is correct. And then we kind of discussed briefly. Yeah, we discussed briefly that they're not quite exactly the same. There's different ranges for them. And if you typed them as degrees and only had degrees, then you could still mix up latitude and longitude because you haven't actually differentiated them in any way. You've added a unit, but they're the same unit, so you can still swap them out. So you don't actually fix the problem. So here we defined two different ones. And the cool thing about units of measure is they're like not really, they're really just annotations. There's nothing really special about these things. There's no built-in conversions. There's no limitations except that you can only hook them to numeric values. So ints, floats can have units of measure, but strings, Boolean, such things can't. In some ways, that's kind of a sad thing because it would be kind of nice to be able to say like, this string has like a max length. You could actually verify that that's the case. Instead, you have to do other things to try to make sure that you're catching those. So this is showing like two types, degrees latitude, degrees longitude. To create one, you just give it the type a name and then put this measure attribute on top or to the side, as in this case. And that will now define a unit of measure, and then you use it like this. So I've created a function here, degrees latitude, degrees longitude. These take a value, these are going to take a float, and you know that because the one dot indicates that this is a float value. And then I'm basically multiplying it using an identity of 1 with that unit of measure tagged. And whenever you're using units of measure, if you do multiplication, it will always multiply a unit of measure onto the value. So in this case, if I did like, maybe I do degrees latitude of 1, and then I do call degrees latitude of 1, and I multiply those two values together. I will now have still a value of 1, but the units will be degrees latitude by degrees latitude. It'll be basically degrees latitude squared. So it will actually kind of compose these things. If I divide it by degrees latitude and degrees longitude, I can get some kind of really bizarre thing where it'd be like 1 degree latitude divided by 1 degree longitude is now 1 degree latitude over degree longitude, which is really kind of weird stuff. So you can do weird stuff with these things. Again, they're just annotations. They're not going to necessarily prevent you from doing something really dumb, but they will at least show you where you might be doing something dumb, which is where it can come in handy. It does also block you from passing things in the wrong way. So moving forward with our example here, the location type, if we now annotate these, that this needs to be a degree latitude and a longitude needs to be a degrees longitude float, we can now no longer pass in the wrong value. So long as we've annotated it correctly, we won't pass in the wrong value to the wrong property here.
Did you put a range on there or something already?
I did not yet. We haven't dealt with the ranges.
So right now it's no different.
Right. Well, it's a little different. You can't pass the two values in. If I had like 20, in the example of Houston, 29 degrees latitude and negative, I think 90 degrees longitude, I can't mix those up here because those annotations will prevent me from. They're basically part of the type checking system. It's like I have to pass them to the correct properties.
You
can't mix those two annotations.
Of, latitude.
No, I get that, but how did I get the value? I don't see how I got a value in at all. How did I get a value in at all? Like,
oh, so like the record syntax is where you kind of like the, let's see.
no, forward, go forward. No, go back.
Here we go. It's like this one. So like here I've added a sum with a location value, and I would like call like degrees latitude on this value and degrees longitude on this value. and that would convert it
But those
into
are
the
just
right.
like two floats. Like
But so now you couldn't do that anymore. You would need to add 29.75 brackets.
bracket. Oh, I have to put the type.
That's right.
Okay, so.
Well, let me keep going, and then we can. I'll show you more clearly how this works.
It's a great chat for you.
Yeah. Okay, so here's our types. The goal really is to make invalid values impossible, as much as we can. Unfortunately, types can only get you so far in most languages. So city still allows, we've kind of covered this earlier, city still allows null on an empty string. Location is allowing a latitude in the outside of a valid range. It allows a longitude outside the valid range. So at some point you have to then start going into other things, like the same thing with null checking in C#. You can add that into the types. I'm not going to go into the C# piece anymore. I'm going to just focus on the F#. But here we have our city type that we looked at earlier. It's again a single case union. And in this case, I have labeled it as a name, as opposed to earlier where I didn't have a label for the parameter value. And then I've also added a static constructor method create that takes that string name and then matches, if it's null or empty string, I throw an invalid argument exception, and otherwise I create my city instance and return it back. So I'm doing basically some guard checking here. Again, even in F#, I am actually been checked for a null. We talked about this earlier that we didn't have to in F#, but you still do in a lot of cases because string can be a null value. A valid string is null. So.
Well, I mean, you won't be able to pass null into create in F#. From C#, yeah, you can pass it.
You can pass in a null in
You
F#.
can create a null string in F#.
Yeah.
You can?
Yeah.
You can either do it with just literal null, or you can do unchecked default of string, and it'll give you a
You
null.
can do that with anything.
Well, yeah.
Technically anything.
So
So
taking the
just by,
basic
just by default, I didn't know you could just say, I just wanted to declare like a value, let X, and it's the type of string, and I can just say null.
Mhm.
I don't know if you can do that.
Because it's like
Let's check your all the beer.
allow valid return, right? It's basically all
That's
those
time.
sometimes it's allowed valid return.
That's, I don't know.
But you know it.
Okay, which is better than nothing. So like we've gotten pretty far with our types. We still need to do a few more things to make sure we're guarding ourselves correctly. Same thing with location. So here, I'm actually doing something slightly different. I've actually made my record signature internal. So this would only be allowed, like basically I'm using this because I want to be able to destructure and pull out the latitude and longitude later using the pattern matching stuff. But then I can expose that latitude and longitude as properties. I mentioned we were going to see this later. This is kind of how you might do this. And then I've got another static constructor here that takes a latitude and a longitude, and then it does the checking for the correct and valid ranges using the units of measure. So this latitude, oh, and you can see it in the bottom right corner. It says that this is a float degrees lat, and this is a float degrees lon. Well, you can't really see the LNG down there, but these have to be like a specific value. And I'm not taking in two floats and then converting them. I'm making the person calling this create those values and then pass them in correctly. So I'm putting the onus on the person calling this and creating this value to put in the right types, not just making it very helpful and saying, give me some floats and I'll fix it for you. And then that doesn't really actually help anything. I need them to do the right thing. So this is exposing those correct types out.
Why are we throwing an exception as opposed to returning an option?
Well, in this case, I'm trying to make this like an exceptional thing. Like I want it to error. I want it to fail hard as soon as it happens. I could make it an option, but an option doesn't really tell you what went wrong. So a better choice here might be to return a choice and have like choice 1 of 2 be a valid value back out, and the choice 2 of 2 be either an exception or a string message telling like what went wrong or what was bad about it. If you look at Scott Vlashin's railroad or bolt success failure, but it's basically the same sort of structure where you're passing back a value, but it's 2 different cases. One is success, one is failure. Returning back that way. This
And that can be abused too if you go too far even with that. I mean, it starts looking kind of like, what choice do I have?
No, we have to, yes.
Yeah, so either one is a valid way to do it, but .NET supports exceptions. In some cases, it's just easier to go ahead and use the exception handling. Try with works. Most of the computation expressions support the try with syntax. Those actually basically transform things into something more like a choice, but they still propagate and can catch those exceptions correctly based on normal .NET usage. So just that's kind of the way I went with it in this example here. All right, so visiting place. Does anyone see anything different with our place type? No. And this is probably indicating that we have a decent design here. Like, place is a single responsibility. It contains a name and a location and provides that back. We changed our city, we changed our location to be more rigid, but the place itself that contains those two things didn't change at all. So we probably did something correct here, because the things that needed to change changed in their one and only place that needed to change, and other things were not affected by that. They are in some ways, like they will take a more restricted version of a value, but the type itself didn't change. So you might get more, you would see more errors throwing back basically, but you wouldn't actually have to change any of your code. It's all localized to those original types we created. So if you want to look more into this sort of stuff, one of the ways of, another way of kind of doing verification, things like that, is to use property-based testing tools. FSCheck is a good one for F#, where you can define properties of types and things like that, and then test based on generators that produce large ranges of values, and test like edge cases and everything else really well, so you can verify that what you're doing is actually being caught correctly. Other similar ways of trying to catch these things are code contracts, which .NET does have. I haven't used those a ton, and I'm not sure how well they carry across over like library boundaries. And then there's also languages that have dependent types. F*, TS*, which is a TypeScript dependently typed language. And then Idris is like a Haskell-based language that's probably one of the more cutting-edge languages that includes this stuff. These actually let you define, like if you said that this is an int, you could say this is like natural integers of like 0 to, you know, whatever. You can define like certain ranges, or this needs to take a list of 3 items or 3 to 5 items. It gives you like a lot more control over what types can be accepted and used. All right, processing requests. How much time do I have left? Like 15 minutes? 20 or so? 20 minutes? Okay. So I think I can get through this. All right, so earlier we talked about the process. We take in 2 cities, we look at the locations, we try to find the distance, and then we convert those distances from meters to feet. All right, so how do we translate? Just described it. So basically we're doing some unit conversion, calculating the inputs to 2 geographic coordinates. And so to define this, we'll start with some types. So we're going to define some function alias types. This syntax here is that this is a pair, 2 cities, and it returns a pair of places. So this is basically going to take 2 strings effectively and return 2 those strings added with the location values as well. The next function takes those 2 places and then returns back an optional float in meters. So this is the distance. Again, it's optional because the places may not have a location. So if they don't have a location, we return that there's no way to find the distance, thus the try aspect of this. Meters to feet ignores that option thing and says, if I have floated meters, I'm going to convert it to a floated feet. And then lastly, we take our pair of places, our float in feet, it's an option, and return a string. This is show. So like show would be like rendering JSON and putting it on a web page.
Right, I gotta run.
Okay.
But Jason's outside. So you guys have.
Okay.
Have a good day.
Thanks, Rob.
See you guys soon.
All right, so retrieving values from other sources. Dimitri, we have in the room, is the author of F#.data.SQL client. And this really has to be seen in Visual Studio to be appreciated. So this, what looks like nasty inline SQL that everyone likes to hate and spit at and everything. Turns out it actually isn't really inline SQL. It's actually type-checked SQL. So hopefully you can see that. As I deleted the E on longitude, I got some red squiggles. And then I'm pretty sure you can't read this, but it says the type provider, F#data SQL command provider, reported an error, invalid column name, longitude. the batch could not be analyzed because of compile error. So it gives me a very informative error message. I can fix that. So this is actually type checking this inline SQL string. There are other ways of including these, like the SQL in here and things, but like for the most part, like what used to be kind of considered really ugly, nasty things to do is actually a part of my type, is built in, has built-in type checking. The application won't build, it won't run. I'm actually guarded against doing some stupid things. The other part of this is that this is actually erased. So this type provider is generating types for me. It's checking the types of the SQL I'm doing, but it's also going to erase all this stuff that it looks like it's doing for me at design time and run with the performance of basically raw ADO.NET. So I get performance benefits, get wonderful things, and I get this fantastic DSL called SQL that's really good at writing DSL. I mean, really good at writing SQL code. It's like 1-to-1. I don't have to worry about an ORM trying to figure out like how is it writing my SQL. I just write the SQL. It's amazing. It has several options. Like in this case, I know I need a single row back, so I can specify that that's what I'm going to get. And then I can use it like so. So I've got a function lookup location. This is implementing that definition I have up here, lookup locations. But this is for a single city. So I get again, I'm using that pattern matching on the single case union. I get the string name out. I'm using that command that I created using the SQL command provider. I call it using execute, and it's actually even generating an execute method that takes the parameter that I've specified. So up here in my SQL, I have it at city. I could add something like and at latitude equals, oops. And latitude equals at latitude. And then here, you'll see that I've got a red squiggle again. It's actually going to generate an execute that now takes a city and a latitude. So I'm getting and generated for me with the right parameters, the right types for these things. You notice this is a float. This is really, really helpful. I'm only writing SQL and everything else is being given to me without me having to write any more. Again, the sum and none explicit pattern matching I'm having to do here, but that's fine. I'm getting the latitude and longitude out. And here, as I'm getting the values out, I'm creating my, my place using my city constructor to make sure I'm getting a valid city name, location constructor create to get a valid value out, and I'm using those degrees latitude and degrees longitude functions to convert latitude and longitude into the correct type. So I'm giving it the Latin long. If I swap these out, then all of a sudden these are going to break because I'm giving back the wrong values. So I need to make sure I'm giving the correct values in here. So again, all these things that we've done to protect ourselves are actually starting to pay off. It's going to break the build. I can't compile, and I'm giving myself a lot of good protections. So then the function lookup locations that implements the signature we created earlier, it takes the pair of cities and returns a pair of places. Just calls lookup location on the start and destination. So I've basically preloaded a database with city names, and I'm going to look those up, convert them into places. And there's that implementation again. Calculating distance. So I basically did a shortcut and used what was built into .NET. They have a implementation of geocoordinate that uses the Haversine algorithm to calculate kind of geospatial distances over a curve of the Earth, curvature of the Earth. So I'm using that. Unfortunately, it only takes raw floats. So I have to basically divide the values I got out by one dot my unit of measure. And then when I get back the result, I now have to multiply back by the new unit. And so Haversine, I'm getting back a raw float again. I have to know that the Haversine formula in .NET is giving me back meters. So now I'm multiplying by 1 meter to get it into meters. And then I can create a function that then converts it into feet, which we haven't done yet. We're just going to try and find distance because we're getting the meters back. Again, I'm using a lot of pattern matching on parameters. So like here, to geocoordinate is using a shortcut syntax here where you use the full word function, and it basically goes right into a pattern match. There is a parameter coming in here, but you don't have to even specify what the parameter name is. If you use function, the parameter that's the last parameter passed in gets passed right into the pattern match syntax. Same thing here on try find distance. uses the function again, and then I'm checking the pair of locations that I get. Actually, this is a pair of places. And one of the nice things about pattern matching on records in F# is similar to what Will was describing earlier. I don't have to pattern match on the entire record structure. I can pattern match on just the particular piece I want. So I'm pattern matching on location, and I'm looking for a case where one place has a location and the second place has a location, and then I do the find distance on that. And I'm running out of time, so I'm going to try and rip through this really quickly. Unfortunately, unit conversion. So meters and feet. I've got a function meters to feet, which takes an input, which is a float meters, and returns back using this conversion function. I looked this up on the Google, so I know it's correct to that specific precision. At least I hope it's correct. We'll see. I don't know. I haven't tried walking all the way here from Houston, so I can't verify that it's exact. All right, and so then at the end, basically we can wrap up the steps. We can compose these functions. We got these separate functions we created. We can map them all together. Remember, try takes a non-optional float in meters and returns a non-optional feet. So option map allows us to adapt that meters to feet function to work with an option of meters, and we'll return an option of feet. Well, what about show now? We need to get it out in some way. So how might we visualize results? So the way I was going to do this is display this in a web browser. We're actually in a web browser right now for this presentation, so that's convenient. Define HTTP resources to process requests, and then render the UI. So serialization, I did something really, really shortcutty. I basically just like printed out a JSON string from the results. And one thing we need to do before we even get there is we need to figure out how to like build this workflow so we get all the way through. So I built this as a mutually recursive function definition. It has receive input that takes those city values, those two different strings, or the two different cities. It then looks at the locations, calls calculate distance. Calculate distance takes the two places, tries to find the distance if it can. If it can't find the distance, it just calls show places. Basically, just jumps to the end. If it does have a distance, then it goes and does the conversion to feet, and then it will show the result, and then serialized result again prints out like a JSON string using the places and the distance. We can make this a little prettier by using defunctionalization, which is basically saying take these function definitions and like lift out a set of cases in the type situation here. So I can actually define a type stage and then have all the different stages that I'm going to be going through my workflow with all the different parameters that are coming in for these. There's actually a paper on defunctionalization that I have linked in this talk if you're curious on more. The nice thing about it is now I can have a single recursive function run workflow in this case that takes a stage and returns a string. And now every time I get the result I want back, I just call run workflow, and it pushes that new case back through here. So input received, I get my cities, I look at locations, return a located value to run workflow. It now goes to the next stage, and so on and so forth as I'm calling all these things. It's basically the exact same thing I had, but it looks a little cleaner. So then we can get all the way down to show, serialized result, return back to JSON, but we haven't quite gotten all the way out yet. Here's the JSON that's going to come out. So I've got a start, a destination, and a distance. Again, start and destination are places. I have to pull this out. You might be wondering, how do we get the HTTP resources? We could use ASP.NET MVC. Maybe since we're just doing JSON, we could use Web API. But of course, we're in F#. Why can't we just model HTTP itself, right? After all, HTTP is just a state machine. It happens to be a really nasty, large one that you can't read at all. But it's still, it's a workflow. It's a state machine in and of itself. And a colleague of mine over in the UK and I have been working on a thing called Freya, which basically implements that state machine for the web. And the way this works is you basically define like a resource. So in this case, that resource is called a Freya machine. And we've created a domain-specific language inside of computation expression syntax. This is actually the query extension part of F#3, where you can basically define your own operators and things like that. And we actually have like a weird inheritance thing going on here. So like we can actually inherit like a common set of patterns and then extend that. So I can extend it with core support, say what methods I want to support here, and then give it like an implementation of what to do when the response status code is 200 OK. I can then route that, and this actually was using the URI template syntax. And so I can say, if I get a request for calc and it has a query string parameter for start and one for destination, now I will route to this handler. So I know I'm getting those two things in my query string as well. I'm not routing just calc or something else. I'm routing like a very specific URI template syntax. And this is kind of jumping back a bit. So this is the common machine. This is what's being used. Kind of a base. If I had additional resources, I could say this is how I'm using. These are the defaults I'm using for all those resource types. Common media types, languages, char sets, those types of things. But we still haven't really mapped the domain. So I know I can get the query string. Here's how I can use that query string. This would usually give you a warning. I've disabled the warning in this case, because again, I know that I can only map to this if I have those two query string parameters, because that routing mechanism requires that URI template syntax be exhaustively matched. So I can explicitly match and know that I'm getting a start and a destination in my query string. I can pull those values out of here using some combinators we have built into this Freya thing. And then I can create my two cities and pass them on through the mechanism that we created earlier in the defunctionalization. You see that here I've called input received, given the cities, and now I'll call run workflow with that stage that I've created. My get handler then does this get, produces the JSON that I get out of the run workflow, and then represents that JSON back on the wire as I'm calling the API. The definition of all this stuff in Freya is like probably 3 or 4 or 5 talks to go into like depths of how that works. So I know a lot of this stuff we've been talking about is like showing how to build the types and all this other stuff. This is more showing like uses of computation expressions to help build out those types, and is well beyond the scope of this specific talk. But here we go, show and tell. So
Paris.
I don't know, Paris may be a,
Not Texas.
yeah.
Same cat.
So we're using Houston, Texas, and San Mateo.
Is this a hidden
California.
supporting, French countries?
Remember, I preloaded these things in my database. So if I don't have them in there, we can try this. So
Didn't strike you to include Paris? I mean,
Paris,
Disappointed here.
Camelot. Oh, let's put a real city. London.
Oh, come on, dude.
Undefined feet. So Paris, one of these doesn't exist. Let's see. How about Adelaide, Australia? Oh, because that one exists. So Paris is just a fictional city. And by the way, in case you're curious, this is what is 53 million. It's hard to read these numbers without commas. Yeah, 53,354,700 roughly 75 feet between London and Adelaide, Australia.
So I should be able to check your system. If you pass twice the same city, that should be 0.
Yep. Maybe, I don't know. I didn't test it that hard. So this is kind of the result here, and then kind of just as a goal is again make invalid states impossible. Provide types from external sources. Client SQL F# SQL client to get data from SQL Server. Declare your app state machine. So in many cases, like you're building a state machine without really thinking about it. In many instances, you can actually really build a state machine and then have that actually run through a lot of the things you're writing. When you do so, it makes it clear like what the steps are, how the process is supposed to flow. Maybe you want to put in places where like that exposes something to a user to then input something else and then progress further. In some cases, it may just need to like run through those steps, and you can build this thing to kind of bounce through on its own with specific rules and kind of have a lightweight rules engine that you're basically defining for your application. Doing so gives you the ability to use like those property-based testing things, because now you're building something that has properties that you can test by having something that's well defined like that, versus just having a bunch of random functions that you're calling and hopefully in the correct order. And then even untyped protocols can benefit from types. So like HTTP is not really known for being a strongly typed thing. There's a kind of an implicit state machine in there. You can model that state machine. One thing we're looking at doing is actually lifting out those rules and making it a pluggable state machine, so you don't have to include the entire thing. You could put your own little pieces on top. You could maybe add WebSockets or something else into that graph of HTTP that you care about using, and have all that stuff be modeled for you. And then there's actually a thing called session types, if you want to look into that, which is basically all about modeling protocols with types and type systems. That we're trying to see if we can adapt what we built into helping model those types of things. So if you had a protocol you wanted to follow, you can implement something to actually help you restrict yourself into you following that protocol correctly when building out your applications. And then lastly, types can't get you all the way all the time. They're really helpful, and having a good type system can really help. Especially like one of the more common things that I've found is often like with building like web apps, the UI binding stuff. If you have an HTML template plus some code, the refactor rename doesn't happen across the two different pieces. So like you fix it in one place, you don't realize it was actually bound over here, and then you like spend 2 hours crying because like something isn't working and you don't know why, and then all of a sudden you find it and you're like, what was I doing? What was I thinking?
This is the Durando experience.
Well, that's a lot of experiences. Angular, I mean, most of the ones that have templates have the same problem. So there are always things that are like gotchas that you can't get all the way through. So finding ways to help adapt those. Maybe it's, again, kind of like the guards we were putting in to help and things what are useful, but you can only go so far. So don't be upset if you can't get all the way. And then lastly, a list of resources and things. There's the link to defunctionalization in case you want to read more about that. I'm sorry, I kind of raced through some of these things. But there's quite a lot of really good information out there in the F# Software Foundation, Scott Blushing's F# for Fun and Profit. And then for domain-driven design in particular, if you search for F# domain-driven design in any search engine, you'll find a ton of stuff. This is like one talk and one perspective of many in doing domain design type things. So.
What's the link to defunctionalization?
Can you put a link to the comments section in the meetup page?
Yeah, I'll do that. I'll link the slides there, and then you can find them there. So that's it. I think I probably ran over my time for questions, but
I think we should take these questions at Murphy's.
I'm sure online they all have questions about like, what did I say for the first half hour? I'm so sorry, everyone. I will do this again and re-record this for those of you who are watching online and suffering the mute button.
I'm still blown away that string can be null.
It's because it's like where is type defined? It's not the call size, right?
So hold that thought.
Yeah.
So just like, out of respect for Open Table, is like I don't want to leave too late, so is like I propose that that we head to Murphy's and keep the discussion going over there. And the first step before doing that is like two things. One is like leave the place the way you found it. So it's like if you have something like this, put it in the trash and stuff. Say thanks to Jason, and like but the bigger one is like a big thanks to Ryan, and maybe how about a big round.
And Matthew, Ian, all of you who are online, I will happily redo this for you guys again if you're interested, or I can help set up other things for you guys too. So thank you for joining.
Thanks everybody for coming. So.